Yes, good morning, my dear students. Today we will be continuing the same chapter which we had done previously. Uh, so today, last class we had done melting point, melting, evaporation, boiling point, condensation, and then the condensation point. So there is one activity, one experiment to show condensation of water vapor. To show condensation of water vapor, it is in page number 59. Okay, so look at there. Aim. What is the aim of the experiment is to show condensation of water vapor. So materials required: a beaker, clear, a small beaker containing water, a Bunsen burner, then a wire gauze, a tripod stand, a cover for the beaker, then a pair of tongs. These are the requirements, clear. And what is the process method? Look at there. Set up your experiments. That means first of all you'll have to set up the apparatus, clear. It is as it is shown in the diagram. Look at their figure or the activity 3.10, and then bring the water in the beaker to a boil. That means bring the water, clear. Then in the beaker, that means put water in the beaker and then starts boiling. Once the water starts boiling, cover the beaker. When the water starts boiling, you cover it, clear, the beaker. After a minute, lift the cover, and observe, clear. Just after 1 minute, clear, or after few minutes, just you can lift the cover, then you can see, you can observe. So what do you observe is the water vapor or steam condenses into water droplets. That means you see the droplets of water in the cover, clear, on the outer side of the cover. So conclusion is, we can conclude that steam condenses into water. Steam condenses into water as soon as it comes in contact with the cooler portion of the plate. Clear? So this is the experiment to prove the condensation of water vapor. Now there is another topic, freezing. Matter changes its state from liquid to solid on further reduction of temperature. That means the matter changes its state. Clear? Matter changes its state from liquid to solid. Liquid to solid on further reduction of temperature. That means on further cooling of temperature. This process is known as what? Freezing. That means the process by which liquid changes into solid on further cooling or further reduction of temperature, that is known as freezing. Clear? So the temperature at which liquid turns into solid is called freezing point. That means the temperature at which a solid turns into the temperature at which liquid turns into solid, that is known as what? Freezing point. Clear? So this is about the freezing point. And there is another topic, sublimation. Now what is sublimation? The process by which solid changes directly into gas on heating without passing through a liquid state is called sublimation. Now see, another topic is sublimation, and sublimation is the process by which solid changes directly into gas without changing into liquid. Solid, it changes from solid to gas directly without changing into liquid, that is on heating, clear, without passing through a liquid state. That is known as what? Sublimation. That means in short form we can say that the process by which solid changes into gas, clear, that is known as what? sublimation. The gaseous state of the substance obtained during sublimation is called sublime. That means the gaseous state of the substance obtained during sublimation, clear, which obtains during sublimation, that is known as what? Sublime. So the substance formed when a gas changes back into its solid state is called sublimate. Clear? So that is known as what? And that means the substance formed when a gas changes back into its solid state is known as what? Sublimate. So this is about sublimation and the sublimate. Then another one, deposition. Now let us see what is deposition. The process by which gas transforms into solid without passing through liquid state is called deposition. Now see, another one is the process by which gas transforms into solid. Clear? Gas transforms into solid. Clear? That is without passing through liquid. Clear? So in the previous one it was the process by which solid changes into gas without changing into liquid, that was known as sublimation. Clear? And it just opposite, the process by which gas transforms into solid without changing into liquid, that is known as what? Deposition. It is also known as desublimation. Clear? That is also known as what? Desublimation. Now see, there is a chart how we can change the different states of matter. Clear? It is a chart shown here in the picture. Shown here. Just look at there. Ice. It is a solid. Clear? So when ice melts, clear? When ice melts, it converts into water. Clear? And water, what will happen when it boils? It converts into steam. Clear? When it converts into steam. And in just a reverse process, the steam on condensation, it changes into what you call it liquid, that is in the form of water. And water on further cooling, clear, that will convert into ice. That means it is the reverse process. First of all, ice melts, clear, into water, clear, and water evaporates in the form of water vapor or in steam, clear, and steam, what will happen on further cooling, what will happen, or condensation, it will convert into water, and water on further cooling, it will convert into ice in the form of solid state. Clear? So this is the chart. Clear? So with this chart we can define what is melting, what is evaporation, what is condensation, what is freezing, and all we can define it easily with the help of this chart. Clear? So remember this one. This is most important chart that you can follow it nicely. What will happen? You can define it, all the states of matter. Okay. Now there is one experiment to show sublimation of ammonium chloride. Materials required is a funnel, clear, then a tripod stand, then one china dish, a small china dish, clear, then a cotton, then ammonium chloride, a wire gauze, and then a Bunsen burner. These are the requirements to prove the experiment or to show sublimation of ammonium chloride. So how to do it? What is the method? Now, first of all, you set up the apparatus. Clear? First of all, you set up as shown it is in the diagram. Then place some ammonium chloride in the china dish, a small what you call it container, china dish. Clear? You place some ammonium chloride there. Then cover the china dish with an inverted funnel. That means you'll have to invert the funnel. Clear? Then plug the opening of the funnel with the help of a piece of cotton in order to prevent the ammonium chloride vapors from escaping into the atmosphere. Then what we have to do? Plug the opening, clear, of the funnel with the help of a piece of cotton. A piece of cotton, you can just place it in order to prevent the ammonium chloride vapor, clear, from escaping into the into the atmosphere. Then what you'll have to do it, heat the china dish with the help of the burner. Then you heat it, clear, heat it. Then what you are observing is the ammonium chloride changes into white vapor. Clear? Ammonium chloride, it changes into white vapor, and then the vapor condenses to form solid ammonium chloride when it comes in contact with the cooler parts of the funnel. Then what will happen? The vapor condenses, clear, in the form of ammonium chloride when it come in contact, clear, when it come in contact with the cooler part of the funnel, clear. Then conclusion, what is the conclusion of the experiment? So that ammonium chloride undergoes sublimation on heating and deposition or desublimation on cooling. Once again, ammonium chloride undergoes sublimation on heating and deposition or desublimation on cooling. So this is the experiment proving that the sublimation of ammonium chloride. Clear? So we will do this much for today, and we will continue in the next class. Okay, thank you.